This is solving systems using the substitution method. The steps for solving systems using the substitution method, the first step is to solve for one variable in one equation. So if you look at my example, just like any other systems of equation problems, you have two equations. So the first step says to solve for one variable in one equation. So they picked the top equation and they rearranged this where you are solving for one variable. They did not get an answer. All they did was rearrange the equation where it says y equals. So it says y equals x plus 2. So you're going to take the x plus 2 so instead of y, they are now plugging in x plus 2 because y is x plus 2. And they are plugging it into the other equation that they did not rearrange yet. So once you plug in this x plus 2, you substitute it into the other equation, making one equation with one variable. So you guys can look at this and see that the whole entire equation only has x's. There is no more y's. So we are only solving for x. Now for step 3, we can solve the one variable equation just like we would do any other equation. You would distribute this 2 to make 2x plus 4 plus x equals 10, and then you would solve for x. So once they get the answer for x, which is x equals 2, then you can solve this like any other elimination problem or systems of equation problem. You're going to just take that x and plug it into one of your original equations, which they use the easier equation, the y minus x equals 2, and you plug that in to solve for y. So we still get a solution as a coordinate whenever we do substitution. This is just another method to solve. Okay, in the next example, 2x plus 3y equals negative 6, and x minus y equals 2. We're going to do this first step, which is to solve for one variable in one equation. So we're going to solve for the variable that is going to take the least amount of work. So we would subtract x from both sides because x is positive, and we want to isolate y to get y by itself. So then this is going to leave us with negative y equals, I'm going to put my x first, so negative x plus, because that's a positive 2, and then I'm going to divide by negative 1, because I can't have a negative variable. So then y would be positive, and x, negative x divided by negative 1 is going to give you a positive x, and then 2 divided by negative 1 is going to give you a negative 2. So now we have solved for one variable in one equation. So instead of y, when we plug in to this equation, we are now going to put x minus 2 instead of putting in y. So I'm going to rewrite the top equation, which this is the equation that I did not do anything with. Just going to rewrite this. So now I'm going to plug in for y into this equation, y is no longer going to be 3y. It's going to be 3 times x minus 2. So I'm going to rewrite 2x plus 3 times x minus 2 equals negative 6. So now our equation, we can just solve for x now because we don't have two variables. We only have one variable, which is x. So the whole equation only has x's. So now we can solve for x. So we're going to distribute first because it has parentheses. So 2x plus 3x minus 6, so we're multiplying. And we're going to combine like terms. 2x plus 3x, so 5x minus 6 equals negative 6. We're going to add 6 to both sides to isolate the x. So we're left with 5x equals 0 because negative 6 plus 6 equals 0. We divide by 5. And x is going to equal 0. So now we can use the variable that we solved for, x, and we can plug it into our original equation. Not any of the equations that I wrote out, but the original equation, which meaning the typed out problem, which the original was x minus y equals 2. That is the equation before I did any arranging or any plugging in. So now I can plug in x equals 0 to solve for y. So x is just 0, so now I'm going to be left with y, negative y equals 2, and then I got to divide by negative 1 to get that negative out from underneath y. So then y is going to be equal to negative 2. So x is going to equal 0 and y is going to equal negative 2. So the answer for this system is going to be 0, negative 2. Okay, if we wanted to check our answer to make sure that the coordinate that we found, 0, negative 2, was correct for the systems, we would go and we would plug this coordinate in. X would be 0 and y would be negative 2. So I would plug in 0 for every x and negative 2 for every y. So 0 plus negative 6 equals negative 6. And as you can see, negative 6 does equal negative 6, so it is true for that equation. And then here, when you have a negative and a negative 2, those two negatives is going to make that a positive, and 2 does equal 2, so this is also a solution. So our solution 0, negative 2 worked for both equations.